Welcome back. In this session, we'll explore message queues and in particular RabbitMQ within a Docker container. I've made this a fairly lightweight session, but at the end of it, you'll have created a local Docker container with RabbitMQ. Then using Postman, you'll be able to publish messages to RabbitMQ and look at the content of those messages. So let's start by explaining what RabbitMQ and Docker have to offer. What is RabbitMQ and how does Docker fit in? In order to understand RabbitMQ, you first need to understand the reason for the usage of message queues. Let's look at a traditional system. So here you might have a checkout, and that checkout service is communicating with an inventory service. Now, messages will be sent between the checkout and the inventory service directly. This works. However, you can end up having instances where the checkout or multiple checkouts are sending multiple messages to the inventory service, and that service may struggle to cope. In that instance, you could look at scaling your inventory service up in order for it to manage multiple checkouts or an increase in the number of messages being sent. Although this works, this doesn't really solve the underlying problem. This is where message queues come in. In the traditional sense, if a checkout cannot send to the inventory service because it's too busy or it's not available, it's going to be stuck in some sort of a wait condition. Now, a message queue is here to alleviate that instance. Let's add a message queue in and see how this changes the solution. So now we've got a message system in place, an MQ. We'll add a label on here. So we'll just call this MQ for the moment. We can then publish messages from the checkout to the message queue, and then equally they can be passed on and consumed by the inventory solution or service. So here we've got our checkout service publishing messages to our queue, and then our inventory service can consume them. And that means if this service is down, the checkout solution can still integrate with the message queue, and again that can be picked up later on. Equally, we can now increase, if we wanted to, our inventory, and we can have multiple instances of those consuming messages from our message queue. As well as that, we can also have the same on the checkout side too. So we can have multiple checkouts all publishing messages to the message queue, and then the inventory solution is able to scale and consume messages that are being published from the checkouts. So what is RabbitMQ? Well, RabbitMQ follows the AMQ protocol, and this is the Advanced Message Queuing Protocol. Now, this is a type of message queue, and it follows this protocol in order to leverage the protocol and provide a more succinct way of exchanging messages. So let's see how that would change our checkout and inventory solution. Let's shrink this down for a sec and move it to one side. So this is just our standard message queue solution. Now what we're going to look at below is RabbitMQ. So let's take our checkout, and then let's take our inventory. So we've got our two services here. How does RabbitMQ connect these two services? If we think of RabbitMQ as our solution here that sits in between our two separate services, so here we're going to call this RabbitMQ. Now, what we've got to think about is our checkout is our producer. So this is going to be sending messages towards RabbitMQ. And in this case, within RabbitMQ, we have an exchange. and it's the exchange that the checkout is going to be sending or publishing messages to. So those messages coming from our producer and land at the exchange. And you can think of an exchange like a post office. It will receive messages and then it will distribute them to however they are addressed to what will be the appropriate queues. And an exchange is connected to a queue by what is known as a binding key. So we're going to have our queue here. So this could be our call it inv queue for inventory. And then we can have potentially multiple queues here. We could have one around inbound. We could have one around shipping. So you can have multiple queues within the system, but an exchange will be linked to a queue based on a binding key. An exchange can be connected to one or many queues, and it's the queues that will be consumed by the inventory service in this case. So the inventory service is going to consume the inventory or from the inventory queue. So we've got a checkout service that is publishing messages to the exchange. The exchange is linked to one or many queues based on a binding key. And then the service will then consume messages from that particular queue. Now, although this design pattern is more complex than our simple message queue solution, it is very similar, but it allows for stronger decoupling. It then also allows for a much more scalable solution. And because of that, it means that what we can do is we can have multiple checkouts, multiple inventory services as well. So we can scale all of this up. And then what we're able to do is we're able to have a single message queue solution here where we may actually have, as well as an inventory solution that is picking up from an inventory queue, we could in fact here have a completely separate system around inbound, which is then consuming from an inbound queue, and that inbound queue can actually be, let's rename this could be being consumed by some sort of SAP service which is dealing with purchase orders, for instance, and those purchase orders could be coming into the exchange and they have a separate binding key to this inbound here, and then it's then consumed by the inbound service. So all of this platform can then be scaled in order to provide a solution that can be used and scaled at enterprise level. Now you understand the basic principles of RabbitMQ, let's see how Docker fits in. To understand Docker, you need to understand virtual machines or VMs. So if we've got a VM, what we actually need to think about and deal with are different layers within that VM. Now, firstly, we've got a layer here around the infrastructure. So you've got your infrastructure that VM will be built upon in essence. You then have within that whole solution the hypervisor. So the hypervisor in this case could be something like VMware. Then at that next level, you've then got your actual virtual machines. So you can have one or multiple virtual machines. And then within each virtual machine, you will have a guest operating system, and then you'll have whatever apps that you want that are sitting within those VMs. So this is our sort of VM, we call it our VM solution or diagram. And then what we're looking at here is we'd have VM1, for instance, VM2, VM3, and VM4. And each one of these virtual machines will have its own copy or its own version, because it could be Windows, it could be Linux, whatever that is, but it'll have its own version of an operating system and then its own app that you want to have within that VM. So this is our VM sort of infrastructure, so to speak, and what we need to deal with when we're talking about VMs. The difference between virtualization from a VM perspective and Docker is the ability to leverage what are known as containers. So if we take this diagram here, what we can look at from a Docker perspective, so we go on here, we're looking at Docker, we've got different things that we need to be able to take care of. So here we've got the same underlying infrastructure this is being built on, in the same that you can have your own personal computer with multiple VMs sat on it, all run under VMware or a server, for instance. And the same with Docker. You can have your underlying infrastructure, but at this level will be the host operating system. And then you will not have your VMs at this level, because with Docker, we're not dealing with VMs in the same way. What we will have is we'll have Docker under the operating system. So with our VM scenario, we have our hypervisor VMware, which will manage VM 1 to 4 in that case. Here, we've got our host operating system. And then within that, we've got our Docker solution here. And then Docker can then manage what is known as containers. And each one of these containers can then contain our app. So these are our containers. And then within here, we can have app 1, app 2, and so forth. And what this means from a Docker perspective is that you're only dealing with creating a container which contains strictly what you care about, your app. With a VM, you have to manage the OS. You've got to configure all of that. You've got to have all of that up front and built, and you're concerned around the whole virtual machine. So if we were to install RabbitMQ, which we can do on a VM, we'd need to build a VM. We have to have the OS. We've got to configure all of that, all sorts of bits there. And then once we've built the VM, we can then install RabbitMQ and have that deployed on it. What we're going to do is we're going to leverage Docker. And by doing that, we can then actually install Docker Desktop and use that in order to create our container, which will contain, in this case, RabbitMQ. So what we're going to do is we're going to install and set up Docker. We're going to have the MQ container built, and then we're going to use Postman in order to test our RabbitMQ service there in order to publish messages and to check and make sure that they are being received into the queue. So what we're going to do next is we're going to look at Docker and work with Docker in order to create our RabbitMQ container. Before we start diving into Docker and creating our RabbitMQ container, what I'd like to do is show you that you can fairly easily download Docker Desktop based on whatever chipset or OS you are using, and this can be done directly from the Docker website. Now, the reason I want to alert you to this is you need to be aware that there are sometimes some further settings that need to be turned on in order to use Docker correctly. So after installing Docker, if you receive an error message similar to what I'm showing here, which talks around enabling virtual machine platform within your BIOS, you know that there is something you need to enable within your BIOS for this. So what is that? Well, depending on whether you've got an AMD processor or an Intel processor, the settings for this within the BIOS will be slightly different. And you can Google your particular motherboard and chipset in order to find this out. What I've done is I've picked up a couple of settings here. So one I'm sharing now, which is an MSI motherboard using an AMD processor. You'll notice that within here you have an SVM mode. So it's this that will need to be turned on in order to enable virtual machine or virtualization within Docker. If, however, you've got something like an ASUS motherboard or you've got an Intel processor, this can be presented in Intel's naming as the VMX, so the Intel Virtualization Technology. And if this is disabled, you'll need to enable this, reboot your machine, and then the error that you've received on launching Docker, similar to this, will then be cleared. So I just wanted to clear that up to make that clear so that you've got that resolved in order to use Docker Desktop. So let's now proceed to build our container within Docker Desktop. We now have Docker Desktop launched. On the left-hand side, we've got a menu for containers, and we can see we have no containers set up at the moment. For images, volumes, and any builds and so forth. In this particular session, we're going to be mainly focusing on containers. So what we want to do now is we want to open the terminal, and from here, we want to now start building our container. In order to do that, we need to run a command. So here we want to run docker run, and then -d, so we've got it in sort of disconnected mode. We're then going to pass the host name, and the host name here, we're just going to call it RMQ. We then want to give our Docker container a name. So here I'm going to call this Rabbit Server. And then for the ports, which is the -p there, we need to map the management port. So we're going to manage that or map that management port to port 8080. So 15672 is the default port, and we're going to map that so that we're now mapping it to port 8080. The second port we need to map is the port around the messages themselves. So they're going to be published on port 5672. Now, when we get to it later, testing in Postman, because we're going to be using the API side, which isn't strictly the sort of messaging ports, we're going to really be doing that on port 8080 in order to push a message via Postman. However, if we were developing our own application and were fully utilizing this RabbitMQ and the messaging side, would be using the port 5672. Now, for this Docker container, we want to actually provide it with an image to use, and that's going to be the RabbitMQ image, and we want to use the 3-management image. And it's as simple as that. So now we can hit return or enter, and here it's now going to attempt to find the RabbitMQ image. It hasn't got it. It's not found that locally, so it's now pulling that down. So it's pulled that down from the sort of global repository within Docker itself, and it's set up this container. We can see we've now got Rabbit Server container here. If we go to images, we can see it's pulled down the RabbitMQ 3-management image there. So it's pulled the image down and it's created a container called Rabbit Server based on that image. What we can do now we've got this set up is we can open up a browser, go to localhost on port 8080, and we can now look to log in to RabbitMQ. Now, in order to log in, we need to provide a username and password. And because as part of our command line call here, if I move this out of the way, make this a bit smaller. On here, we didn't provide any parameters for a username and password word. So from that perspective, we're just going to have the default, which is guest. So guest is the username and guest is the password. Again, we're setting this up very much in a test environment. This isn't open externally at all. It's running on localhost within this particular infrastructure. So we can log in here now. And now from here, we've got access to the RabbitMQ management portal for the Rabbit server container. How easy was that, eh? So that's really simple in order to get that set up. What we want to be able to start doing is we want to look at creating an exchange and then creating a queue and ensuring that our messages that get sent to the exchange will then get diverted or provided to a queue. So let's look at doing that now. When we talk about RabbitMQ and exchanges and queues, what we need to be able to do is build three elements. We need to build an exchange, we need a queue, and then we need a binding key. And that binding key tells the exchange what queue to deliver those messages to. So let's look at building an exchange. So firstly, we need to give the exchange a name. We're going to call this Luke Test. Then we need to choose a type. Now, there are 4 different types within RabbitMQ. The first one that we want to talk about is direct. So direct will basically check the message itself, and then that message will get a routing key. So we get a message, we have a routing key, and then the routing key will get compared to the binding key for an exact match. So we know that an exchange is going to have a binding to a queue based on a binding key. And what we're going to have is a message that has a key, and we're going to check to make sure that there is an exact match. The next is fan out. So in our checkout scenario, the checkout will send a message, and the exchange would then duplicate the message for every queue that it knows about. So that's fan out. We then have headers. And with headers, the routing key is completely ignored, and it's matched based on the header data that's provided as part of that message. We then have topics. Topics enable us to do a partial match. So if we had a routing key of item.beer and a binding key that was called item.any, that would match because it's matching anything which is item dot. So there are our main types. Within RabbitMQ, there is also something called default. It's unique to RabbitMQ, so it's not part of the AMQ message model. And with that, the routing key is matched directly to the queue name itself. So we're going to set up a queue just with Luke Test, and then we can hit Add Exchange. And now we've got our default ones that are installed as part of the RabbitMQ setup, and also our new exchange, which is Luke Test. Then we can look at creating a queue. So we go into queues and streams, and we go add a new queue. And now we want to give this queue a name. So we were talking about our sort of inventory. So potentially we could call this Luke Inventory. And then we can hit Add Queue. So there we go. We've got our queue and we've got our exchange. We now need to be able to link the exchange to a queue using a binding. So we've got to have a binding key. So if we click on our exchange, we've got our exchange Luke Test. We can then go to bindings. And here we can then look at adding a binding. So to what queue? We're going to call this queue Luke. Let me just go back to queues and yeah, it was Luke inventory. So we can go back on here, Q. So it's to Q Luke inventory. And then we need to give it a binding key. So we can call this on here for the binding key, inventory -key. And then we can hit bind. And there we go. So we go back to exchanges, we click Luke test. Luke test has got a binding key of Luke inventory. A binding key of inventory key, and that's going to bind to Q Luke inventory. So we've now got an exchange with a key of inventory -key that links to the Q Luke inventory. Now we've set this up, what we're able to look to do is we can utilize Postman in order to send a test message to Luke test. And because this exchange is set up as a direct, what it will be looking for is a routing key. So we're going to provide a routing key of inventory key. And what we should see is our number of messages increase here. So let's do that now. I've now got Postman open. So we want to create a new request. And on this new request, we're going to be doing a post. And here we're going to call this Luke Exchange publish, because we're going to publish a message to Luke Exchange. Now we need the URL for this. So the URL for this will be our local host at port 8080 /APIs /exchanges, and then we've got here. Next, we then need to put our exchange. So our exchange was Luke test. So here we're going to go Luke test and then publish. So that's our endpoint we need to call. Now what we need to do is we need to add our authorization headers here. So this is just basic authorization, and we'll provide our username and password here of guest. We then need to provide headers, and the header we want to provide here is the content type. And the content type here is going to be application JSON. So endpoint, our authorization, and the headers. Next, we need to go to our body, and here we need to be able to provide some JSON, and the format for that JSON is here. So here we've got our properties. If we've got any properties, we need to provide our routing key here, our payload here, and it's a type string. So our routing key, if we go back to we go back to RabbitMQ, we know that if we go to our exchange, test Luke, our routing key needs to be inventory -key. That will be our routing key. That directs it, well, we're already directing it to exchange, but that then directs it to the queue that we potentially want to get our exchange to talk to. So it's the binding that we are providing in the routing key. Then we need to provide our test payload. So in this instance, if we wanted to provide something, let me bring it on screen. So here we've got our JSON payload. So we've got a checkout ID, we've got an item ID, quantity, and a stamp, for instance. So something very, very basic. So here we can provide that into the payload here section or string. We would just need to convert that into a string in order to do that. So let's grab that here. We will put that in here, and now we've got that converted into a string. And that's basically it. So what we can now do is hit send and see what happens. And here we've got routed true. So what that means is the message has been sent and it's been successfully routed. So if I was going to change this key to the word keys and hit send, we get routed false because there is no binding on the Luke test exchange with a routing key of inventory keys. And then if I send another one, so we'll have that as 86 and the item here ZZZZ, we submit that and there we get true. Okay, that's great, but has it really sent? Well, we've got 200 OK, so we know that it's been received, but in order to check that we've actually physically received that item, we'll need to check the queue. So if we go to queues, we can see here we've got 2 messages, so it's looking very likely that we successfully received that item. What we want to do from here then is we want to have a look to see the content of the message to see what messages we've actually received. So if I select that queue, we go in here, we can go get messages, and we can go where we want 2 of the messages. Hit get messages, and here we can see our first message that we sent here, which is 7.6, and the other one, which was 8.6. There we go. So we've got item ID ZZZ. So there we go. And then we can continually publish multiple messages. So our checkout is sending multiple, 4, 5, 6, and then what we'll have in RabbitMQ, they'll get received and we'll get multiple of those messages there. So there we go, we've got 6 there. And again, I can go get 6 of the messages, and there we go, we've got those through there. Now what we would end up doing is now we've got this system working, we would then tie up the inventory service in order to collect these and basically read them, mark them as being processed through, so that this queue basically goes down as it's been processed. And it's as simple as that. So that is RabbitMQ and Docker. And what is great about Docker is we can very, very quickly redeploy, recreate this particular container. So we've got this container running at the moment. I can hit delete and physically delete that container. What that means now, if I go into Postman, if I try and send a message, I'm going to get an error, because now that container does not exist at all. And if we open up the browser and try and browse where we were before, it can't be reached, it's not there. And what's great about Docker is if we want to deploy a new version or we've got some changes to make, what we can do is we can then recreate that container, and basically we've got access to that again. So if we hit refresh, we can go to localhost. Let's just clear that out. It'll probably ask us to sign in again. No, it still remembered that. And there we go. It's up and running again. So we can have a look. Obviously, all of our data isn't there. The exchanges aren't there because it's completely deleted everything. But what we're saying here is if we want to be able to test something, it's very easy to bring it down, bring it back up, and we can do that in a live environment. So if we've got to make a change to this container, what we always want to ensure we do with containers, we want to rebuild them, because we want to be able to have a process where we can redeploy, recreate very quickly, very easily, without having a whole load of configuration like you would have potentially for some of the VMs. You need to worry about the OS, different version, patching, etc. On this, we're just dealing with the container. Hopefully that's been useful, and it's good to actually see that we've been able to create a container running RabbitMQ and actually be able to build an exchange, create a queue, add a binding key, and be able to test the sending of our messages within Postman. That concludes this session. If there's anything else that you would like me to cover, or if you have questions about RabbitMQ and Docker, please feel free to comment or reach out to me on LinkedIn. And don't forget to subscribe so you don't miss the latest content.